Think of the modern developer's ultimate messy habit, the raw folder. It is a digital dumping ground where code files, PDF research papers, and smartphone photos of whiteboard sketches are all tossed into one place. Power users like AI researcher Andrej Karpathy use this method on purpose. Centralizing every scrap of reference material into a single directory guarantees you always know exactly where your project's context lives. But when you hand that exact same folder over to an AI assistant, the system breaks down. The sheer volume of unstructured mixed media creates a wall of digital noise that the model has to chew through. A human can glance at a scattered desk and naturally intuit the relationship between a rough diagram and a block of code. An AI agent, however, struggles to parse that chaos efficiently without a strict, predefined structure. When you feed a raw folder directly to a large language model, you immediately overload its short-term memory limits. Forcing the model to process massive, noisy prompts repeatedly causes your computational costs to spike dramatically. We call this token waste. Every time you ask a question, it blindly reads thousands of lines of completely irrelevant data before even formulating an answer. Feeding raw data to an agent creates a hard architectural limit. Without a scalable data structure, the context window remains a permanent ceiling on performance. Graphify was built specifically to solve this token waste. Instead of giving your AI a heavy reading assignment, it provides an intelligent, pre-calculated map of your project. You hand it a chaotic, multimodal folder, and it transforms that scattered data into an interconnected, queryable knowledge graph. It builds this map in two passes. First, it extracts rigid structure from your code using abstract syntax trees, a deterministic way of mapping out code grammar. This plots out functions, classes, and call graphs entirely locally without requiring an expensive call to an LLM API. In the second pass, Claude Vision sub-agents handle the abstract material. Graphify reads whiteboard photos, screenshots, and PDFs, extracting the human rationale and linking those concepts directly into the rigid codebase network. The result bridges strict programmatic architecture with messy human reasoning into a single map. Rather than relying on standard vector embeddings, the system clusters this mapped data using graph topology-based community detection, meaning it groups concepts entirely by the density of their connecting edges. This clustering automatically calculates what the creators call God nodes. These are the highest degree conceptual anchors that structurally hold the entire project together. When more AI agent needs to understand the repository, it navigates directly through these God nodes to find exact conceptual paths, skipping the inefficient keyword grepping entirely. Bypassing the raw files and reading this summarized graph report yields a massive efficiency gain. On a mixed media repository, this method delivers up to a 71.5x reduction in tokens per query. That radical compression happens because your assistant is finally querying a targeted index instead of processing a raw text dump. However, this optimized workflow comes with strict operational limits. Graphify suffers from severe ecosystem lock-in, as it is heavily tied to Claude Code and a select few terminal agents to function properly. Even getting started presents immediate user friction. Due to a naming conflict, the actual PyPI package must be installed as Graphify, spelled with two Ys, which routinely confuses new users. This line graph maps token savings against repository size, and it reveals a critical constraint. If your project contains fewer than 6 files, the savings curve stays completely flat. The massive token reduction only materializes after you cross the threshold into large, complex corpuses. Graphify is an enterprise-scale architecture tool designed to make chaotic datasets manageable. It is not a universal quick fix for small scripts. As we push the limits of local context windows, the future of AI interaction relies on mapped structures over massive context dumps. Effective agentic workflows depend on persistent structural memory. Without a shared map, coordinating multiple agents across a massive codebase leads to prohibitive latency and rising API costs. If you found this overview of Graphify helpful, subscribe to the channel for more deep dives into the best open-source AI repositories.